Alright, so let us start our lecture today. So last time we were trying to solve second order differential equation with constant coefficient and those equations homogeneous, right? So the equation that we were looking at has the following form. So ax second plus bx prime plus c is equal to 0, and abc are constant. Right? So this is second order. This is linear because you see that you just multiply the derivative with something. So this is linear. This is linear. This is homogeneous. All right, so this is called second order linear homogeneous second order linear differential equation, right? Last time we considered the first case number one. In case number one, when you consider this delta, which is b squared minus 4ac, right? When delta is greater than 0, the characteristic equation has two solutions, right? So you have a squared plus br plus c is equal to 0, right? So how can you write the characteristic equation? You just put abc from here down there, and you associate a with a square because a is the constant of the second order derivative, right? And b is associated to r because b is the constant, the coefficient of the first order derivative, and c is a constant because it doesn't have derivative, right? So this is the characteristic equation. If delta is greater than 0, this characteristic equation has two solutions, right? Has two solutions. So the first one will be minus b plus the square root of delta dividing by 2a, and the second one will be minus b minus square root of delta dividing by 2a. Right? So when delta is positive, this characteristic equation has two solutions. The first one is minus b plus the square root of delta dividing by 2a, and the second one will be minus b minus the square root of delta dividing by 2a. Right? In this case, the equation one has two solutions. All right. So in this case, the first the equation one has two solutions, which is the e to the r1t and x2 is e to the r2t. Right? And we know that if x1 and x2 are both solution, then the linear combination of x1 and x2 will also be solution. Then the general solution has the form. Right, so xt will be c1 x1t plus c2 x2t, right? When c1 and c2 are constant. It's clear? So I explain again. In order to solve a second order differential equation with constant coefficient, what you do is the first step is to write out the characteristic equation. So the characteristic equation is a squared plus br plus c. This a is associated to r squared because it is associated to the second derivative. This b is associated to r because this is associated to the first derivative, and this c doesn't have any derivative, so it is a constant. And when you write out this quadratic form, which is the characteristic equation, you look into delta, which is b squared minus 4ac. If delta is strictly greater than 0, then the characteristic equation has two solutions. The first one is minus b plus square root of delta dividing by 2a, and the second one is minus b minus square root of delta dividing by 2a. In this case, the equation 1 has two solutions. The first one is the exponential of r1t, and the second one is exponential of r2t. Then you linear combine x1 and x2, which is x1 times c1 plus x2 times c2, in which c1 and c2 are constant. Then you get the general solution for 1. Right? Questions? So case number 2, which is more important, which is also important, which is delta is negative. Right? So when delta is negative, from last time, how many solutions do we have for the quadratic form? Yes?
2.
2. What are they?
R1 is negative b plus I times the square root of delta over 2a, and R2 is negative b minus I to the square root of delta over 2a.
Yes. Can you sign at the back of the paper, please? Right. So in the case of when delta is negative, you still have to take the square root of this delta, right? So in this case, the square root of delta will be I minus delta. So I is the imagined number. So this is like when you take the square root of minus 3, you're gonna take the square root of 3. Takes and times that with this number I, right? So in this case, the R1 will be minus b plus I to the square root of delta divided by 2a, and R2 will be minus I, b minus I square root of delta dividing by 2a. All right? Questions? Now, what are the two solutions of the differential equation? Yes?
It would still just be x1 is e to the r1t and x2
Yes.
is
Can you sign the back of the paper, please? Alright, so x1 will still be e to r1t. x2 will still be e to r2t. But r1 and r2 now are complex numbers. So how do you express exponential of a complex number? So what is the exponential of a complex number, right? So suppose that you have a complex number, a plus bi, like 2 plus 3i. So once it's the exponential of 2 plus 3i. Yes?
You could write it as e to the 2 times e to the 3i.
Yes? Can you sign the back of the paper, please? So this is e to the 2 and e to the 3i. So how can I write e to the 3i?
Do you take the natural log?
No. So what is e to the I? Hmm?
E to the square root of
No. So this is the so-called Euler formula. This is Euler formula. So if you have e to the alpha I, this is going to be cosinus of alpha plus I sinus of alpha. good. So basically now, so in this case you're gonna have what? You have e to the alpha of 2 cosinus of 3 plus I sinus of 3. Right? Questions? So basically this is the so-called Euler formula. So when you have a real number and when you have exponential of a complex number, so you're gonna split the real part and the imaginary part. So you're gonna have e to the 2 times e to the 3i, right? The e to the 2 you compute in the classical way, but the e to the 3i will be cosinus of 3 plus I sinus of 3. Right? So this is the so-called Euler formula. Now, let us go back to this business. So how can I write x1 and x2 in terms of using this Euler formula? Right, so I have already x1 and x2, which is e to the r1t, and x2 will be e to the r2t, right? And r1 and r2 are complex number because you see that here you have an I. And so I just gave you the formula for e to the I something. How can I write e to the r1t using this? Yes?
Would it be so you could split it up as, so it would be e to the, you have to remove your constant, so it would be e.
The first thing you do is you split the real and the imaginary part, right?
Right, so it would be e to the, it would be cosine of t times negative b over 2a, because if you separated the terms, but the denominator needs to be cosine t times negative b over 2a plus I times the sine of t times the square root of negative delta over 2a.
Right. Can you say at the back of the paper, please? So to compute x1, you're going to use this formula, right? So in order to use the formula, you're going to split the real and the imaginary part. So this is going to give you e to the power minus b over 2a plus I square root of delta over 2a times t, right? So here you have real and imaginary part. So it's crucial that you split them. So you split the real and the imaginary part, right? So then now you're going to develop this. So this is going to be e to the power minus 2a t, right? Plus square root of minus delta over 2a times t times I, right? The first step is always to split as a real and imaginary part, because the real part is always an exponential, and the imaginary part will give you cosinus and sinus, right? So you're going to split this, and you're going to have e to the power of minus 2at, which is a standard exponential. And now you have to deal with this imaginary part. So you have minus square root delta over 2at times e times I, right? It's good. So I explain again. To compute x1, you want to use the formulas of r1. The formula of r1 is minus b plus 2a plus I square root of minus delta over 2a times t. You split them. So the first thing gives you b over 2a times t. The second one gives you square root of delta over 2a times t times I. Yes?
Why is it a negative delta?
Negative delta because delta is negative.
But isn't that why we took the I out? So that it would be positive?
Right, so how do you take the square root of minus 3? You take the I out, in the leftover you cannot keep delta, right? So you have to take minus of this guy.
Yeah, so didn't we already take the I out there?
So it's going to be minus of minus delta. So, right, so here in this case delta is minus 3.
Yeah.
Right?
Yep.
So the square root of 3 is I times square root of 3. So this is minus delta. Right? It's good. Because delta is negative, so the minus of delta will be positive. So this is standard as well. It's good. All right, so now what we do is we split the imaginary part and the real part. So the real part will give you minus b over 2a, and the imaginary part will give you minus the square root of minus delta over 2a times t times I, right? Here you have a sum, so you split the sum. The first one will give you a standard exponential. The second one will give you an exponential of an I. Now I'm going to use this Euler's formula. So I have e to the power b minus 2a t cosinus of square root of delta over 2a times t plus I sinus of square root of delta over 2a times t. Good. Here you have this guy times I. This guy's exponential of this guy times I will give you cosinus of square root minus square root delta over 2a times c plus I sinus of minus square root delta over 2a times c. Right. Questions? Clear?
Is all of that an exponential?
No. The exponential is the factor outside. Right? So here you split the imaginary part and the real part. The real part will be outside. You don't care about the real part. Now, you do the Euler formula for the part which is inside. You're going to get cosinus plus m sinus of this guy. Question? That's good. Now let us compute the second guy, which is x2. So we want to do a lot of practice so that you remember how to use those formula. So x2 is e to the r2t. So how can I compute x2? Yes?
We can use the same method that we used there, so we can start by plugging in our number for R2, and the only difference is that it's going to have a minus sign on the imaginary term with I, so the answer should come out the same. So it will come out to e to the negative b over 2a times t times the cosine of negative square root of negative delta over 2a times t plus I times the sine of negative square root of negative delta over 2a times t.
Yes, can you sign at the back of the paper, please? So you're gonna use the same method, right? So first you're gonna write that in terms of the real part and the imaginary part. So you have e to the power minus b over 2a minus over 2a times t. Right? So the only difference is the minus sign. So in the two cases, the only difference between that case and this case is the sign of I. So here you have plus and here you have minus. So x2 will have exactly the same form, except that you change the plus and the minus. So now you have minus b over 2a minus I minus square root delta over 2a times t, right? Now you're gonna split. So this is b over 2a times t minus I square root of delta over 2a t, right? So how do we continue? Yes?
We split up the exponential, so it'll be e to the negative b times t over 2a, and then that whole term times e to the negative I times the square root of negative delta over 2a times t.
Yes. Can you sign the back of the paper, please? So now I'm gonna split, right? So here this is real. I'm gonna put it outside. So here you have b over 2a t. Here you have an imaginary part. So I'm gonna do it in the second term, right? So here you're gonna get minus square root of 2a times t times I. Right? So the real part, I'm gonna keep it. I don't do anything with the real part. So this I'm gonna put it here. Now what happened with the imaginary part? Yes?
If you do the Euler's formula and then the negative square root of negative delta over 2at, that would be your alpha.
Yes. Can you say in the back of the paper, please? So now I'm gonna use the Euler formula, right? So here you're gonna get cosinus of square root of minus of delta over 2a times t plus I sinus of minus of square root of delta over 2a times t. Right? Questions? How can I get rid of the minus here and the minus here? Yes?
Cosine of negative theta is just cosine theta, and sine of negative theta is negative sine theta.
Can you say at the back of the paper, please? So I want to get rid of this minus and minus. So for a cosinus, you know that cosinus of minus x is going to be cosinus of x. So this minus doesn't have any role, right? So cosinus of minus x will be cosinus of x. It's good. So for the first one, I'm gonna get e to power b over 2a t cosinus of square root of minus delta over 2a times t, right? So you can remove the minus. Now, sinus of minus x will be minus of sinus x. All right? Questions? Cosinus of minus x will be the same, and minus of sinus x will be sinus of minus x will be minus of sinus x. So to get rid of this minus, I'm gonna put a minus outside. Minus I sinus of square root of delta over 2a times t. Right? Questions? The conclusion is that, okay, for the second case, you're gonna do the same thing, exactly the same thing, but this is more complicated because you have to deal with this I number. But to deal with this I number, what you do is to use the Euler formula, right? But now I'm gonna give you a simplified version of this so that you can remember and do it in with the exercise, so it's easier. Now I'm gonna write down the form for the for the x1 and x2. Right, so for x1, you're gonna have e to the power minus 2at, and you're gonna have cosinus of square root of minus delta over 2a times t plus I sinus of square root of minus delta over 2a times t. Right? And x2 will be e to power minus b over 2at cosinus of square root of minus delta over 2a t minus I sinus of square root minus delta over 2at. Right, so this is the formula that you have. This is, so I write out the form for x1 here, up here, and I write out the form for x2 right here. So what is the difference between x1 and x2? Yes?
It's a plus I sign, and on the same one it's a negative I sign.
Yes, can you say at the back of the paper, please? So the only difference between x1 and x2 are the plus and the minus. So in other words, x1 is a linear combination of this first guy, and x2 will be the linear combination of the second guy. So x1 t. So now I define x1 t will be e to power b over 2a t. Cosinus of the square root of minus delta over 2a t. And then I'm gonna have I exponential minus b over 2a t. Sinus of square root of delta over 2a t. Right? I'm gonna develop this guy. So I'm gonna multiply, I'm gonna distribute exponential inside the sum. I'm gonna multiply this exponential to the cosinus and this exponential to the sinus. So I have e to power b over 2at times cosinus plus I e to power b over 2at times sinus. Alright? And for the second guys, the only difference is the minus. Right, so x2 t will be e to power b over 2at cosinus of the square root of delta over 2a t minus I e to b over 2at sinus of square root minus b delta over 2at. Right? So the only difference in the first form and the second form is the plus and the minus. Alright? Which means that we don't have to consider x1 and x2 to be of this form. We can consider x1 to be the first one and the second one. So I define this guy to be x1 t bar and this guy to be x2 t bar. Right? Then you're going to have x1t will be x1t bar plus I x2t bar, and x2t will be x2t bar minus I x2t. Alright? I explain again. Now, I want to emphasize the difference between x1 and x2. So the only difference between x1 and x2 is the sign of the I, right? So here I have minus and here I have plus. Right? So let us look into the form of x1. x1 is an exponential times cosinus plus I times sinus. What I do is I distribute this exponential into cosinus and sinus. So here I distribute this guy into cosinus and this guy into sinus. That's why I get this new formula. Right? This is the form of x1, and this is the form of x2. The difference is the plus and the minus. Alright? Now, I call the first one the exponential times the cosinus to be x1 bar, and the exponential times the sinus to be x2 bar. Right? So x will be x1 bar plus I times x2 bar t. Right? And x2 will be x2 bar t minus I times x2 bar t. It's good? Yes?
Why is this something like x?
X1. Can you say at the back of the paper, please? Right? So I'm gonna say that okay, x1 t is x1 bar plus I x2 bar, and x2 is x1 bar minus I x2 bar. Right? Now I'm gonna say that x2 and x1 bar and x2 bar are also solution of the equation. x1 bar and x2 bar are also solution. And I'm gonna work with x1 bar and x2 bar because they're simpler, right? But I'm gonna say that x1 bar and x2 bar are also solution of the equation, meaning that if I consider only this guy is a solution of the equation. If I consider this guy separately, this is also a solution of the equation. And because of that, instead of x1 and x2, I'm gonna work with x1 bar and x2 bar because it's simpler. Why x1 bar and x2 bar? So this is This is x1 bar, right? And this is x2 bar. So you have x1 is this guy plus I times this guy, and x2 is this guy minus I times this guy. So I wrote it right here, and my claim is that x1 bar and x2 bar, they are also solution of this differential equation. So this is hard questions. Can you express x1 bar in terms of x1 and x2? So I want to know, I want to express x1 as some linear combination of x1 and x2.
Would it be x1 minus x2 bar t?
So let me, this is approaching the solution. Can you sign the back of the paper, please? But this is not yet the correct answer. Now, I have what? I have x1. I have x1 is x1 bar plus I x2 bar, right? x2 is x1 bar minus I x2 bar. And I want to write x1 bar as a linear combination of x2 and x1. Yes?
Would it be
No. So I have x1 is x1 bar plus I is x2 bar. Yes?
Could we use, so our first equation we have up there, if we rearranged it to say that x1 bar is equal to x1 minus I times x2 bar, and then we use our second equation down there for x2 bar, could we solve that one for x2 bar and then plug it into the first one, or would that just cancel out our terms?
This is very close to solution. Can you sign at the back of the paper, please? Yes.
are you just trying to solve x1 bar in that system there?
Yes, I want to solve x1 bar in terms of x1 and x2.
So we just have x1 plus x2 all over 2.
Excellent. Can you sign at the back of the paper, please? So x1 bar will be x1 plus x2 over 2. That's it. Right? You just take the sum of x1 and x2. Right? You get the x1 bar. It's clear. Right, so this is x1 over 2 plus x2 over 2. So how do you see that? So you have x1 plus x2 will be x1 bar plus I x2 bar plus x1 bar minus I x2 bar. Right? You take the sum and the 2 minus will cancel. Alright? So x1 bar plus x1 plus x2 will give you 2x1 bar. It's good. Explain again. Now I have x1 is x1 bar plus I x2 bar, and x2 is x1 bar minus I x2 bar. Right? I'm gonna say that x1 bar is half of the average of x1 plus x2. Why is it? Because when you take the sum of x1 and x2, you have x1 plus I minus x plus x1 minus I. So this minus and this minus will cancel out. Right? So you are left with 2x1 bar. Similarly, I want to compute x2. So what is x2? Yes?
Would it be x1 minus x2 over -2i?
Yes. Over 2i. Can you say in the back of the paper, please? Right, so you're gonna take the difference of x1 and x2 over 2i. Why? Because when you take the difference between x1 and x2, you have x1 bar plus I x2 minus x1 bar plus 2i plus I x2. Right? So when you take the difference between x1 and x2, you're gonna take the difference between x1 plus I x2 and x1 minus I x2, and you get 2i x2 bar. right? So x1 will be x1 over 2 plus x2 over 2, and x2 will be x1 over 2i minus x2 over 2i. And because x1 and x2 are solution, then x1 bar is x2 bar are also solution. Why? We discussed this last time. Remember that? We have x1 is a solution, x2 is a solution, then the linear combination of x1 and x2 is also solution, right? Why? Can you remind me?
Because their linear combination is in the same subspace, so her subspace is.
Anyone remember why? You take a linear combination of two solutions of this equation, then this is true. So let us do it again. So you have what? You have x1 is a solution, right? So which means that, so x1 is a solution, which means that x1 second a plus b x1 prime plus c x1 is 0, right? And x2 is a solution. So you have a x2 second plus b x2 second plus c x2 is also 0, right? This is what we are trying to solve. We will solve for it. So x1 and x2, they are both solutions of the equation. So you can write down the form of the equation. You have a x1 second plus b x1 prime plus c x1 is going to be 0, and a x2 second plus b x2 prime plus c x2 is also 0. Now I'm gonna prove that x1 bar is also a solution to this equation. How do I do it? Yes?
Well, you plug x1 bar into the formula for differential, which you write out a x1 bar double prime plus b x1 bar prime plus c x1 bar, and then you compute what the second derivative and first derivative is of x1 bar and make sure that it solves the equation.
Yes. Can you say at the back of the paper, please? Now you want to solve that x1 bar is also a solution, right? So what you do is the following. We want x1 bar is also a solution. All right. You want that x1 bar is also a solution, so you just replace x1 bar into the equation. So here I have what? Here I have a x1 over 2 plus x2 over 2 prime plus b x1 over 2 plus x2 over 2 prime plus c x1 over 2 plus x2 over 2 is 0, right? You want that x1 bar is also a solution, so you just replace x1 bar into the equation, and you replace the formula of x1 bar here. So I just replace x1 plus over 2 plus x2 over 2 to the place of x1 bar. Now, how can I prove that this is 0? Yes.
You take the second derivative of that expression, the first derivative of that expression, and solve out the equation to see if they are indeed 0.
Right. Can you say at the back of the paper, please? So I'm gonna take the second derivative, but I'm gonna group all of x1. Right? I'm gonna take the derivative, but I group all of x1 and I group all of x2. Right? So I'm gonna take what? A x1 second over 2 plus x2 second over 2 plus b x1 prime over 2 plus x2 prime over 2 plus c x1 over 2 plus x2 over 2, right? So I group all of the x1. I have a x1 second over 2 plus b x1 prime over 2 plus c x1 over 2. This is 1, right? So I group all of x1 and I group all of x2. So I have a x2 second over 2 plus b x2 over 2 prime plus c x2. Right? And I want this to be 0. Why is it 0? Right? So, to solve that x1 by is a solution, I plug the form of x1 by inside. This is x1 over 2 plus x2 over 2. Right? Now I'm gonna develop the formula. I'm gonna group all of x1 and all of x2. And now I claim that this is 0. Why? Yes?
You can just multiply both sides by 2 to get rid of the denominator. And then, like, because we already know that x1 is the solution, it just be 0
Right.
plus 0.
Can you say at the back of the paper, please? Right? So when you group all of x1 and x2, you're going to see that they are all 0. Right? So this guy is 0. And this guy is 0. Because when you multiply this with 2, you have this one. Right? Right? So this guy is 0 because this guy is 0. Right? So x1 second over 2 plus b x1 prime over 2 plus c x1 over 2 is 0, since 2 times of that is 0. b x1 prime over 2 plus c x1 over 2 is 0, and a x2 prime over 2 plus b x2 prime over 2 plus c x2 over 2 is 0, since 2 times of that is 0. Right? It's good. To solve, so in other words, if you have 2 solutions, you linear combine them. So you have a linear combination of the 2 solutions. You want to solve that this is a solution of the equation. You just plug it inside the equation. You split all of the x1 and x2, and all of the x1 will be 0, and all of the x2 will be 0. Right? In this case, I plug the form x1 by into the equation. I have x1 over 2, x2 over 2. So I group all of x1 and I group all of x2. So when I group all of the x1, this gives you 0, and when I group all of the x2, this gives you 0, because this is just multiplying the equation with some constant. Right? Questions? Now let us try to check for x2 bar. Right? So x2 bar is also a solution because you have a x2 second plus b x2 prime plus c x2 by 0. Right? Now I want to check that x2 bar is also a solution. How do I do that? Yes?
Just same thing as last time, just plug in the x1 minus x2 over 2i.
Yes. Can you say at the back of the paper, please? So you have a x1 over 2i minus x2 over 2i second plus b x1 over 2i minus x2 over 2i prime plus c x1 over 2i minus x2 over 2i is also 0. Alright? So what is the next step? Yes?
You're taking the derivative and grouping like x1s and x2.
Yes, can you say in the back of the paper, please? Now I'm gonna group all of x1 and x2, right? So I have a x1 second over 2i plus b x1 prime over 2i plus c x1 over 2i. And the other one is a x1 prime over minus 2i. So I'm gonna put a minus outside. So I have plus b x1 prime over 2i plus c x1 over 2i. So sorry. Right? So to show that x2 bar is the solution, you plug the form of x2 inside, and you group all of x1 and all of x2, right? And you get a 0. Why is it? Yes?
Because we previously proved that both x1 and x2 are solutions to the equation, and you can just factor out the 1 over 2i.
Right. Because this is 0 and this is 0, right? Because the first one is 0 because x1 is a solution, right? So you have a x1 prime over 2i plus b x1 prime over 2i plus c x1 over 2i is 0, since you just have 1 over 2i, a x1 second plus b x1 prime plus c x1 is 0, right? So the first term is 0 because you can factorize out the factor 1 over 2i, and the inside is 0. And similarly, you also have a x2 over 2i plus b x2 prime over 2i plus c x2 over 2i. It's also 0 because you can put the 1 over 2i outside. So you have a x2 prime plus b x2 prime plus c x2 is 0, right? So in other words, instead of working with this formula of x1 and x2, you only have to work with x1 bar and x2 bar, because and then they are nicer and simpler, right? So instead of working with x1 and x2, we can work with x1 and x2 bar, right? Questions? It's good. Right. So now let me summarize everything that we've done into one formula, and this formula you have to memorize for the exam. So again, this is case number 2. You have what? You have a x second plus bx prime plus cx is 0, right? And the characteristic equation will be a r squared plus br plus c is going to be 0, right? So in the second case, you're going to have the same characteristic equation, which is a r squared plus br plus c is 0. The delta function in this case will be the same, but b squared minus 5, and this is negative, right? The delta will be negative. In this case, you have two solutions. So R1 will be minus b plus I, the square root of minus delta over 2a. And R2 will be minus b minus I, square root of minus delta over 2a. Right? Then we have two solutions. So h1 bar t is going to be e to the power minus b over 2at cosinus of minus square root delta over 2a. And x2 bar will be e to power minus b over 2at sinus of minus square root delta over 2a. Right? And the general solution will be the linear combination of x1 bar and x2 bar. Solution will be x1t, xt is c1 x1t plus c2 x2t. All right? It's good. I explain again. All right? So in the previous computation, you see that I computed x1 and x2. Those formulas are complicated. So here, we prove that, okay, instead of working with x1 and x2, you can work with x1 bar and x2 bar. Because x1 bar and x2 bar have simpler formulas. And this is the table. You have this equation, a is x second plus bx prime plus cx is 0. You write down the quadratic form or the characteristic equation. You consider the delta, which is b squared minus 4ac. In this case, delta is negative, so you have two complex solutions, right? So in this case, you also have two solutions, which is of this form, and the general solution will be the linear combination of these two guys. Questions? Right. So let us try to do some exercise. So let us try to do some exercise on this. Exercise x second plus x prime plus x is going to be 0. Solution. In this case, we have, again, the second order differential equation. So what is the characteristic equation for this differential equation? Yes?
So r, a, b, and c are all 1, so it will be r squared plus r plus 1 equals 0.
Yes, can you sign and I can prepare please? So the first thing you do is you write out the characteristic equation. You have r squared plus r plus 1 is 0. So what is the delta in this case? Yes?
1 minus 4.
Yes. So in this case, this is 1 because this is the constant here, minus 4 times 1 times 1, right? So in this case, ABC are both 1. Right? So this is b squared minus 4ac. Right? So the delta will be b squared minus 4ac. So it's going to be 1 minus 4 times 1 times 1, and this is minus 3. All right? So what is the two solutions of this characteristic equation? Yes?
Then we have e to the 1/2 of.
No, the two solutions of the characteristic equation only.
That'll be negative 1 over 2t plus.
So the R1 will be minus B plus square root of delta over 2A, right? So in this case, B is 1.
Negative 1 plus square root of negative 3 all over 2.
Can you sign the paper, please? So this is minus 1 plus here you have the square root of minus 3, right, over 2. So this is minus 1 plus I square root of 3 over 2. Is good? So what is the second solution? Yes?
Minus 1 minus the square root of negative 3 over 2.
Right. Can you sign the back of the paper, please? So for the second solution, you only need to replace the minus, the plus here by the minus. All right? right? So here, let us. So the two solutions will be -1 plus or minus I square root of 3 over 2. It's good. So what is the general? What is the two solutions? Those solutions that we have here. Yes.
x1 bar is e to the negative 1/2 t times cosine square root of 3 over 2.
Right. Can you say it about the paper, please? So you can have x1 bar t is e to the minus 1/2 t cosinus of square root of 3 over 2t. And x2 bar will be the same except that you replace the cosinus and the sinus. Alright? So here you have what? You have minus 1/2 over 3 over 2. That's square root of 3 over 2. Right? So one thing so that you can remember this formula is the following. First, you look into this minus 1/2, which is not giving you the I. So this minus 1/2 will go to this minus 1/2. Alright? So the real part will go to the exponential, and the imaginary part will go to the cosinus and the sinus. Alright? This is simple. So you don't have to remember all of this formula. So what you do is that, okay, you look into the real part, you have minus 1/2. So this minus 1/2 will go to the exponential. And here you look into the coefficient of the I. You don't care about the sign because it's plus and minus. But you're going to put it into the cosinus and the sinus. That's it. So let us do another example. Alright, so now let us do another example. Let us try to solve x second plus 3x prime plus 7 is 0. Right? Solution. So what is the characteristic equation? Yes?
A is 1, so it's just r squared, 3r plus 3r plus 7 is 0.
Yes, can you say at the back of the paper, please? So here is r squared, right? So this is 1, so I put this one here. Right? So it's not important. So I put this 3 here, 3r squared, and I put this 7 here, so 7r is 0. Alright? So the coefficient of x second is 1, so I put it down, so nothing happened. And the coefficient of x prime is 3, I put it down, I have 3r. The coefficient of x is 7, so I have 7. And this is the equation. R squared plus 3r plus 7 is 0. Right? Now, this is the delta function. What is the delta function? Yes?
9 minus 4 times 7.
Right. Can you say at the back of the paper, please? You're going to take this square. So you have 3 square. So this is going to be square. And you multiply the coefficient of the last. So this, right, so you have r squared plus 3r plus 7 is going to be 0. So this guy, you're going to take a square. Square. And the coefficient of the last and the first one, you're going to multiply with 4 times and minus 4 times. Alright, so what you do is the delta is 3 squared minus 4 times 1 times 7, and this is 9 minus 28, and this is minus 17, 19. Right? you take the 3, you take the square, and you take the difference between the product of the first and the last coefficient times 4. So you have 3 squared minus 4 times 1 times 7, and this is 9 minus 28, and this is minus 19, right? So what are the two solutions? Yes?
R1 is negative 3 plus I squared of 19 all over 2, and R2 is negative 3 minus I squared of 19 over 2.
Yes, can you sign the back of the paper, please? So now you have R1, which is minus 3 plus square root minus 19 over 2. Alright, and this is minus 3 plus I square root 19 over 2. And this is minus 3 over 2 plus I square root 19 over 2. Alright? So R2 will be the same. Minus 3 over 2 minus I square root 19 over 2. Except that you change the plus into the minus. Right? Now, what are the two solutions? Yes?
X1 bar is e to the negative 3 over 2t times cosine of square root 19 over 2t.
Yes.
And then x2 bar is
Yes, yes.
3 over 2t sine of
Yes.
square root 19 over 2t.
Yes, can you sign the back of the paper, please? So now, you don't care about the plus or the minus here, you just care about the minus, but the real part and the imaginary part. So the first one gives you, so e to the power minus 3 over 2t. Alright? So you look into the minus 3 over 2, you put a t and you take the exponential. So, and the second one is square root of 19 over 2. This gives you cosinus of square root of 19 over 2. Right? And then for the second solution, you just have to change this cosinus into the sinus. So you have the e to minus over 2t. You change sinus over 2t. All right? So this is simple, very simple to remember. I explain again. In this case, you have the characteristic equation, which is r squared plus 3r plus 7 is 0. The delta will give you minus 19. All right? So the first r1 will give you minus 3 over 2 plus square root minus 19 over 2. And this is minus 3 over 2 plus I square root 19 over 2. And the other one is minus 3 half minus I square root 19 over 2. Right? Now you look into the coefficient of the real part and the imaginary part. In the imaginary part, you don't care about the sign because you have plus and minus. So for the real part, you have minus 3 over 2. So you put it into the argument of exponential. So you have exponential minus 3 over 2t. The other term is 19 over 2, which is associated to this I. You're going to put the cosinus of that and the sinus of that. And in both cases, don't forget the t. All right? The t has to be everywhere, right? Questions? So this is very simple. So let us consider another example. Example. You have x second plus 4x is 0. All right? Now, what is the characteristic equation? Yes?
R squared plus 4 plus 0, 0. Sorry, R squared plus 0. R squared plus 4 plus 0.
Yes. Can you say at the back of the paper, please? It's r squared plus 4 is 0. Right? Because you don't have the coefficient of x prime, so you don't worry about x prime. Now, the characteristic equation is r squared plus 4 is 0. What are the two solutions of this guy? For this guy, you don't even have to compute the delta, right? So this is straightforward. So what are the two solutions? Yes.
Positive 2i and negative
Yes, can you sign at the back of the paper, please? Right. So in this case, you don't even need to use the formula because r squared is minus 4, right? Which means that r is plus, r1 and 2 is plus or minus the square root of 4, which gives you plus or minus 2i. All right? So you don't have the real part even. Here you have 0. Right, so now let us look into 0 plus 2i, plus or minus 2i, right? So this is the form of r1 and r2. I put a 0 so that we remember what to do with the 0. So what are the two solutions for this differential equation? Yes?
Would it be 1 times cosine of 2t, and the other one would be sine of 2t?
Right, can you sign at the back of the paper, please? Right, so this is so you remember that here you have a real part which is 0. So I still keep the 0. So I'm gonna put exponential of 0t. Right? Exponential of 0t will be 1. So the number 2 here will give me cosinus of 2t. Right? So but exponential of 0 is 1, so this is cosinus of 2t. Alright? So for the second solution, you just replace cosinus by sinus. Sinus of 2t. And those are the two solutions of the equation. I explain again. In this case, you have x seconds plus 4x is 0. The characteristic equation would be r squared plus 4 is equal to 0. Right? Which means that r squared is minus 4. You don't have to use the delta function because this case is so simple. So in this case, you have r1, 2 will be plus or minus square root of 4 minus 4. So this is plus or minus 2i. All right? In this case, the real part is 0. Which means that when you take the exponential of 0 times c, you get 1. So this is not important. So the important one is the number 2 here. So this number 2 will give you cosinus of 2t, right? So so the first solution is cosinus of 2t, and the second solution is sinus of 2t. Questions? Yes?
Should it not be cosine 2it and sine 2it?
No, there's no I. Right? So in the formula for x1 by and x2 by, there's no I. Because the I, where's the I coming from? The I is coming from exponential of I of this whole thing. And the exponential of I will give you cosinus plus I sinus. Right? So I remove the I have cosinus and sinus. Other questions? It's good? Right. So let us try to solve another example. So now let us have a more difficult example, which is suppose that x1 is e to the power minus c and x2 is e to the power minus 2t. Find the equation. Now we don't solve the equation. Suppose that you have the solution already. You want to find the two suppose that you have the two solutions for the equation already. You want to find the equation. right? So in this case, you have x1 is e to power minus 3t, and x2 is e to power minus 2t. You want to find the equation. Of course, this is case 1. This is case number 1 because in the case number 2, you have cosinus and sinus times exponential. But if you have only the exponential, this is case number 1, right? So, any ideas how to find the equation? Yes?
So, since this is formed by using dice for R, you can just backtrack this and find R1 and R2 as R1 equals negative 3 and R2 equals negative 2, and then use that to form.
So what is 1 and R2 in this case?
R1 is equal to negative 3 and R2 is equal to negative 2.
Yes, can you sign the back of the paper, please? So this is case number 1, right? So, because the two solutions are exponential, so it should be case number 1. Case number 1. Right, so in the case number 1, the two solutions are exponential of R1t. So the two solutions will be exponential of R1t and exponential of R2t. Right? In the first case, the two solutions are exponential of R1 and R2. Which means that, okay, I'm gonna have R1 is minus 3 and R2 is going to be minus 2. Yes?
Then do we do R plus 3 times R plus 2 all equals 0?
Yes, can you sign the back of the paper, please? Right. So, so R1 is minus 3, R2 is minus 2. The two solutions of the characteristic equation. Right? So in this case, minus 3 and minus 2, they're both solutions of the characteristic equation, right? So which means that the characteristic equation has to have the form. Has the form R minus R1, R minus R2. Right? Because they are both solutions of the characteristic equation. So the characteristic equation has to have the form R minus R1 and R minus R2. We're going to continue this on Thursday.